The second method of solving a system of equations algebraically is using what's called the elimination or the addition method. And the way this works is we want to first identify a pair of terms in the system that have the same variable and coefficients with the same magnitude, but opposite signs. And so example would be 2x and negative 2x, or 3y and negative 3y. If necessary, we can rewrite one or both of those so that this situation takes place using properties of equality and multiplication. The point of this is that when we have 2x and negative x, if we add those terms together, they cancel out, giving us 0 and eliminating the variable they're attached to. And it puts us in the same situation that we had with substitution, where we have an equation with only one variable, and then we follow the same steps as before to finish. So solving by elimination usually is when we have a system where both equations are in standard form, and we can do a quick visual inspection by stacking the equations like we would an addition problem, making sure to match up the variables as well as the constant on the other side of the equal sign. And we want to look and see, do we notice anything special? Like for instance, the negative y and the y. Those are pairs that have the same variable and coefficients with the same magnitude, but the signs are opposite. So what happens here is that when we go to add these expressions together, well, we add 2x and 3x to get 5x, but when we add negative y and y, we get 0y. That eliminates that variable, and then we're left with a constant of 15. So 5x equals 15, we can solve for x and then follow our same prompts as before, where we substitute x back into another of the original equations and we solve for the other point. So it's very similar in how we get the result. The beginning is just slightly different. Now, when we do our visual inspection, if none of the values are opposites, we can make changes to the equation so that they become opposites. So if you look at the y term, notice how they are opposite sign, but they are not opposite coefficients. And so we need to make a change. What we can do is our multiplication property, and we want to try and change negative y. We want it to become negative 2y. So that way it's opposite of the positive 2y. So the easiest way to do that is just take this equation and multiply it by 2. We can distribute, and now we're going to get a new equation, 6x minus 2y equals 14. Now we can go ahead and add these two equations, and we don't need this one anymore. 7x, these two cancel, equals 35, x equals 5, and then we continue to solve like we have. And here we can go ahead and do it again. And there we get our solution. Now, which method is best? Well, it kind of depends. It may be a matter of personal preference, or the equations may be set up in a way that is more beneficial to one method or the other. Substitution is sometimes easier when one variable is already isolated, or it's very easy to get the variable isolated. If I notice one of my variables has a coefficient of 1, substitution might be the way to go. However, elimination is often easier when we're dealing with equations in standard form, and we like to look for patterns such as identical terms, so that a quick multiplication of negative 1 will go ahead and make those terms opposite, allowing us to cancel. If the equation already contains opposite terms, then we are definitely set up for elimination method. Or if one term is an integer multiple of another one, this equation would just take a quick multiplication of -2 in order for us to be able to eliminate the y terms. So at the end of the day, it's going to be more about pattern recognition to try and determine what's going to be the fastest, most efficient way to evaluate this problem.